Hi everyone, let's continue with the next operation, which is tools native template. This is only the reasoning, not like the Mac connector where we take one tool and execute it. This one is much cooler because now you can reason upon one or multiple tools and even create or get chaining together by the LLM model based on your tool input. I will show you later on also a demo what is possible here. Let's get started with the tool request, and I will close all my here the agent prompt template. We go to the tools native. So this is how a simple tool looks like. I'm providing next to the template instruction and dataset array, which is the tools. And in the tools, I'm providing really tools based on a certain LLM JSON schema. You have to provide it exactly in this format with what is the name of the function, the type function, name of the function, description, so the LLM can reason upon it, and then the properties arguments you may have. So you can see we are providing these different types here and different tools which we will give it for reasoning. And below we are going to see a response. The only thing which I want to mention here is that between Anthropic and the rest of the world, there is a big difference in terms of the way the tools are provided. So Anthropic has here an input schema and the others don't have it. But anyway, that should be, that's documented and you can use it basically with the same approach like Anthropic does it. We can put this back and the rest looks good. So let's get started with OpenAI. We need to add a listener which is called tools. So let's go here and we add a listener, and this will be called tools. So let's go in, add tools, rename the flow, which will be tools native template, tools native template. Why do we call it tools native template? Because this is a native function calling of the LLM providers. Majority, they have a very similar input type, so we unified it, except as I mentioned for Anthropic. So there you have to use the Anthropic format, but the output format will be very similar. It's the same basically. So let's drag and drop the tooling here and we will fill it out, but let me also paste the attributes. So we have the format reply. We paste it here. So, and in the tools template, we can go here and start copying. So we have the first one is template, payload.template, payload.template. We have payload.instructions, instructions. Oh, I didn't do the good job here in writing. And then we had data, hopefully, no, data set. And finally, we have payload.tools. Correct? Yes. Okay. So that's it. Let me save it and it will start redeploying. So basically, we are going to ask two questions. Number one will be, let's here, just save it. What is the capital of Switzerland? By providing all the different tools we have gone through. So get temperature, you have get rain probability, you have get delivery date. But we are asking a general question where you don't actually need a tool for. So let's see what the LLM will reply according to the template and instruction. It's not really much what we are giving here, but just to give you a flavor of what it looks like. So it's deploying, and now it is deployed 4 endpoints. Let's go. So we hit it, and it will say probably it's Switzerland, and this is how it looks like. So no tool used, right? So response is this one. But what if we say now, so we have 2 different tools. I will just first go with this one. So you can see what is the temperature. So it will give you just the payload with the tools saying this function you should be calling with these 2 parameters. And you can take this response and execute it using Mule. And if I would add here now another one and the probability for raining, so now you can see it will give you 2 advices with 2 different tools. Yeah, and give you also what should be the parameter to use. So I can say here, this is Vienna. Yeah, so it should change basically the parameter. And that's the cool thing about it, that it will use its reasoning to suggest the tool execution, and then you can use these parameters to execute the tooling itself. I don't have to save it. Let's go to Anthropic. Yeah, it's basically the same. If I execute, it will tell me, yeah, you were looking to execute this tooling. And here you can see the tool, what was executed. That's basically how Anthropic works. Now let me show you the other demo which we built with it. That's the right MCP demo where I can ask the same question. So what is the capital of Switzerland? And here we are using both MCP and inference connector. You can see standard answer, but I can also ask check inventory for mule test 0. And it will give me something here, which is the inventory details. This is the number. I can further continue and say, okay, this is the inventory. Then only, or that's if available quantity is more than 10,000 units, only then create a sales order, only then create a sales order and use the order number to create a delivery. So that's basically what I can do. And you can see this is a more complex request to the agent. And this agent has been built with tools native template where we are reasoning again and again and evaluating if the reasoning should be completed or the user request is fulfilled. We use the tools template and the agent defined prompt template to allow the reasoning. So you can see here, yes, it was able to identify we have more than 10,000 units available. A sales order has been created. Subsequently, the delivery has been created. And you can see the chaining here. It used, first of all, mule test 0. It found out there are more than 10,000 units. Then it used the create the sales order for this using what was before. And then the order output is used to create the delivery. And that's pretty cool because that shows you the power of chaining within MuleSoft using the inference connector plus MCP. So that's actually possible, and we are going to share this at a later stage on our GitHub repo so keep an eye open for this demo. But that was it from the tools native template reasoning. And we will continue in the next session with the image operations.